Yo, 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 this is Mr. O. What's up, Mr. O here. And today we're going to learn about linear programming. Have you ever thought about, how these businesses make decisions for their companies and how do they gain the maximum profit or how can they limit their expenses or how they can maximize their resources, and that's called optimization. Optimization is finding the, I guess, cost friendly, or this is the idea of the business and economy to understand how they can gain much more. And one of the type of optimization is called linear programming, which we can identify and use it the logic of system of linear equation and inequalities. Okay, so let's go ahead now here. Let's try to understand it first. The objective function is the formula that businesses uses to understand how they can maximize or minimize their cost or gain their profit. Okay, constraint here are is the system of the inequalities that part of the condition based on their businesses. Okay, for math, let's say this is our system here, x greater than 0. That means all the positive values of x. All the positive values of x are on the right side of our plane or in the first and fourth quadrant, right? And while our y greater than 0, these are all the above the x-axis. So means say is over here, everything above here. So if you will see your quadrant, it will be only first quadrant, okay? Because on the first quadrant, the value of x and y are both positive. And that's why our plane here, x and y plane, looks like just the first quadrant, okay? That's the reason there, okay? So that's already good. So we know that the graph is only the first quadrant, okay? So x plus 3y less than or equal to 15. We can graph this one. Um, so we can solve for the x here, or for the y. Find the slope in their form. So this will give you x plus 3y less than or equal to 15. So 3y less than or equal to negative x plus 15. Divide everything by 3 there. Y is less than or equal to negative x over 3 plus 5, right? So this equation here will be now y less than or equal to negative x over 3 plus 5, right? Let me erase this one here. The other equation we're going to have is 4x plus y less than or equal to 16, which we know if you move the 4x to the other side, it will give us y is less than or equal to negative 4x plus 16. Okay, so let's graph them. Okay, so first we know that this is the first quadrant, and this is will give us the first quadrant, both of them. The third one here is that we're gonna start at 5. 1, 2, 3, 4, 5. So we're gonna start right here, and down the slope is negative 1/3. So down 1/3, down 1/3, down 1/3, down 1/3, down 1/3. Okay, so the graph of that one will be just this red line here. And we're shading the bottom part, only the bottom part, because it's less than. So everything right here. Now, next is this y less than or equal to negative 4x plus 16. 16, so this is 5, 6, 7, 8, 9, 10. That's 10 there. 11, 12, 13, 14, 15, 16. This is 16. That's my y-intercept. Down 4 over 1. Down 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1, down 1, 2, 3, 4 over 1. Okay. And the graph will be something like this, and it's less than. So we're going to highlight only this portion here. But since This portion here is not an overlapping, it's not part of the solution. I can cross it out, and I only need literally is just this area here, right? This only thing I need, that portion here. Okay? That's the only thing I need, right? So to make the story short, our visible shaded region is just this portion here. We don't need anything beyond outside this circle here. Okay? So the challenge now here is I know that if you're this your company, this your formula, you can pick any of the solution portion here. But for you to maximize it, you need to find the vertex. The vertex or the vertices are the corners of the shaded region. So in this case here, I'm gonna use pink one here. This corner here, that corner there, this corner here, and this one here are your vertices. Okay, those are the one will give you if it's maximum or minimum. Correct. If you pick any on this shaded region, it will work, but that's not gonna give you the maximum and minimum. So for us to find the points here, you can just look at the graph, or you can use the system of equation. Sometimes it's accurate that you can see from the graph itself. Sometimes it's not. So you have to learn both ways. So for us to know, let's say A, B, C, and D here, we know here that point A is 0, 0. That's definite. This one here is, if we're gonna erase some here, let me erase some portion here. I know that this is 1, 2, 3, 4. That's D here is 4 comma 0, right? And I know also that B here, based on the y-intercept, B there is going to be 5. B is 0 comma 5, okay? C here is a challenge. It's the intersection between the line C and line D. It's the blue and the red one. If you can see from the graph and you know it's precise and accurate, go ahead. But let me show you a way how to do it. This is the C, the blue line is coming from this equation. And the red line came the intersection of these two equations. So what I'm gonna do is I'm gonna solve it mathematically. I'm gonna do it in a using substitution. Since this is letter y here and this letter y here, I can set them equal to each other. I'm gonna put here negative x over 3 plus 5 is equal to negative 4x plus 16. Okay, I'm gonna assume that they're equal there because I will apply system of linear. I'm gonna use substitution method. So I'm gonna combine the like terms, minus 5 here, minus 5 there. That will give me negative x over 3 is equal to negative 4x plus 11. Then I'm gonna multiply everything here by 3, by 3, by 3. This cross out. Negative x equal to negative 12x plus 33. And then I'm going to move this negative 12x to the left, making this 11x is equal to 33. So therefore, x equal to 3. Then I will plug in the 3 to one of this equation, to this one here, to solve for the y. So I'm going to plug it to here, negative 4 times 3 plus 16. So negative 12 plus 16, that will give me a 4 for the y value. So therefore, that intersection of C is 3 comma 4. If you look at it, 1, 2, 3, and then 1, 2, 3, 4. Yeah, so 3 and 4 is right. So again, I'm just showing you one way because sometimes the number could be in the hundreds or thousand or a fraction, and you can get the vertex. And for you to get that one, you gotta use substitution or elimination method there. Okay. All right. So therefore, we have our vertices A, D, B, and C. What are we going to do here to find the maximum? We're going to apply it to our objective function. Okay. So these are the x's, these are the y's. So obviously, so using 3x plus 2y for letter A here, I'm gonna make it like a table here. Let's say a table. So I'm gonna plug that in to the 3x plus 2y. So 3 times 0 plus 2 times 0, the value of z here is 0. If we plug in the 4, so it's going to be 3 times 4 plus 2 times 0. 2 times 0 is 2, 3 times 4 is going to give me 12. 3 times 0 plus 2 times 5, that will give me 3 times 0 is 0. 2 times 5 is 10. 0 plus 5 is 10. And 3 times 4 plus, no, I'm wrong. It's not 3 times 4. 3 times 3. 3 times 3 plus 2 times 4. That will give you 9 plus 8. That will give you 17. So therefore, the minimum value will happen obviously when it's 0, 0. And the maximum will happen at point C, 3, 4. Okay? Applying it in a real life situation, let's do this one here. JC Computers produces both laptop and desktop computers. So let's say that X is the number of laptop and Y here is the number of desktop computers. Okay, desktop. Laptop computers take 2 cubic feet of space, and desktop computers take up 5 cubic feet of spaces. Okay, first we have to understand what is given here. Obviously, we cannot get a negative number of laptop. We cannot get a number of negative desktop. Okay, so we can say that x is greater than or equal to 0, and the desktop is y greater than equal to 0. All right, so we know that. Now, the maximum capacity on the delivery truck is 800 cubic feet. So if you own this JP computers, you have a 2 cubic feet for every laptop, and you have 5 for the desktop space wise. But the most you can have is only 800. So how can you make your constraint or your formula there? So you know that the computer for a laptop can make 2x because 2 cubic feet times the quantity, how many laptop computer you have, plus 5y, right? But the most you can have, the capacity is only 800. So would it be bigger, greater than, or less than? It could has to be less than. It cannot be more than 800 because if your capacity that you will have for the both computers will be more than 800, it will not fit, right? So it has to be less than, and it could be equal to 800, right? So there you go. Okay. Our due to demand, they need to load at least 300 laptops. So the laptop is X. So due to demand, that there should be 300 at least or equal to 300 laptop there. How many of each should they load on the truck to maximize the profit? So there is our constraint. Okay, but here they profit 225 on each laptop, so $225 laptop, so X, plus $280 for the desktop computer. This will identify their maximum profit. So this is your objective function here. Okay. So let's graph it first. So we know that x greater than 0 will give, and y greater than 0 will give us the first quadrant. Again, let me repeat that one. X greater than 0 will give us everything on the right side on the x-axis, which is everything. Let me highlight big. Everything right here. will give us for the x greater than equal to 0. And while the y greater than 0, everything above the x-axis, which is there, so you can see that the blue and red overlap on the first quadrant. Okay, so I'm gonna erase that one just to let you know about that. But I need you to write this too because this is important. That you have to understand that laptops and desktop cannot be negative. It can be zero and a positive integer on this case. Okay. Anyway, so x greater than equal to 300. Where's 300? So we have to come up with a plan here. So let's say this will be 20. So this will be 1, 2, 3, 4, 5. This will be 100. So 1, 2, 3, 4, 5 is another 200, 200. 1, 2, 3, 4, 5. This is a 300. So means say the graph of the 300 will be right here. And since that's greater than, that goes everything to the right side. Okay, everything on the right side of the blue line. Okay, that's the yellow one. Okay, that's our shaded region so far. Now let's do the other one. 2x plus 8y less than or equal to 800. Let me move this one a little bit here and solve it. We can do it two ways. You can isolate the y here, or we can use the x-intercept. Let's do the x-intercept to make it faster. X-intercept y must be equal to 0, so 2x less than or equal to, now let me cross it out, plus 5 times 0 less than or equal to 800. We know 5 times 0 is canceled there. Divide by 2, divide by 2. So x there will be around equal to 400. So 400 will be somewhere here. 1, 2, 3, 4, 5. This is the 400 section. So this is the point. And for the y-intercept, again, y-intercept here, x is equal to 0. So 2 times 0 plus 5y less than equal to 800. So 2 times 0 is cancel out, divide everything by 5. 800 divided by 5 is 160. So go the same here, 20, 40, 60, 80, 100. That's 100 there. 1, 2, 3, 4, 5. That's your 200. So 160 is right, 160, that's 180. 160 is right here. So I'm going to connect both of those points. The intercept of this kind of ugly. Okay, there you go. And that is less than, so we have to shade the bottom portion there. So I'm going to use a blue one there. Maybe a lighter pink one here. If I shade this one here, there's no shade over here. It's not going to overlap the yellow from here. So I don't have to do this one here, but I'm just going to show it to you. And you can see where they overlap. Where they overlap, guys, the yellow and the pink. The yellow and pink overlap right here. This shaded region here, this blue one here, okay? So that is the important key. That's the important part of our, let's just shaded visible region, we call it. So again, in this kind of problem, we need the vertices. So the vertices of this triangular shaded region here is this, and that portion there. We know that one of the point there, A there will be, let's say 300, 0. The B there, let's say this is the A, B, and C. B there is 400 comma 0, and the value of C here. Okay, so on this line here in the blue line, we know that x there is equal to 300, right? And the pink one here is the equation 2x plus 5y less than to 800. Let's have space here. There you go. So 2x plus 5y less than or equal to 800. I'm going to plug in the 300 right on the x here. So this will give me 300 plus 5y is equal to 800 for now. This will be 600 plus 5y equals to 800. So this will be 5y is equal to 200. If you divide it by 5, y is equal to 40. So therefore, this point here is, what is that point? That is 300 comma 40. Meaning to say that, go back there, we can have 300 laptop or 0 desktop, or 400 laptop or 0 desktop, or we could have 300 laptop and 40 desktop. Okay, and again, after we find the vertices, we will plug that one on our objective function or on the maximum profit formula. Okay, I'm gonna make a table again here. So let me put it right here on the side. So my A are 300 comma 0. My B is 400 comma 0. And my C here is 300 comma 40. So I'm going to plug that one in the formula. So 225 times x here is 300 plus 280 times 0. We know that's going to be canceled. Okay, so 225 times 300, that will give us 67,500. That is the profit that they will gain. If we pick 400, so 225 times 400 plus 280 times 0. So that will be 225 times 400. The company, the JP company, will earn here 90,000. But if you pick the 300 here, so 225 times 300 plus 280 times 4, that will give us 225 times 300, which we had it already a while ago, 67,900, 67,500 plus 280 times 4 will give us 1120, and you add that one to 67,500, that will, hold on, did I miss something here? 60, hold on, let me double check our answer here. 300 times 225 is 67,500 plus 280 times 40. Oh, we put 4 here, 40. 40 times 40, 11,1200 plus 67,500. The answer is 78,700. So where can JP Computers earn more here? Is it 67,500? Is it 90,000 or 78,700? The answer is that they will earn more if they pick option B, 400 desktop, 400 laptop, 400x, so the value of x 400, 400 laptop. Okay, there you go. That's how we apply and solve for linear programming. And I hope you learned something here. Kaboom.